is Denis Gagne, and Denis is a well-known expert in the Triple Crown, DMN, BPMN, CMMN, and Denis is also the CEO of the company that implemented Trisotech DMN engine, that's probably one of the closest to the DMN standard, and implementing all features plus additional. You can check it online. But this year, Denis will share his views of the common use of generative AI and compare this with traditional symbolic AI. So hopefully it will give us a higher view. And to bring this concept to life, Denis will do live demonstration as well. Okay, Denis, take over. Thank you.
Thank you, Jacob. Yeah, so I'm jumping on the bandwagon too, or I'd rather call it on the rocket, and I'll explain a little bit what I mean. But so this work I'm presenting is a personal side project that I started around Christmas time last year, and a little bit like Gary just reported, I felt like I was running in front of a tiger. Rather than an elephant in the room, it's a tiger, and it was moving really fast, and it was catching up and passing me all the time. So anyway, let me report what was my experience with this experimentation. So first caveat, I'm not going to talk about how to create LLMs. I'm not going to talk about whether this is, ethically correct and copyright and safety and all this. I'm just going to present some generalized concept and some learning lessons that I have, and everything that I've done was done with the Trisotech platform. This content is inspired by a lot of people. I've been reading way too much, a lot of companies that are pioneering stuff, and tons of research paper on ArcLive. So I'm not necessarily referencing everybody properly everywhere, but I'm acknowledging all this reading that I've been doing. So let's start very high level, demystifying AI. Here, I wanted to make a comment that I'm just looking at this from a non-debate positioning. So I'm not trying to create a debate. I'm just saying, let's separate, natural intelligence for human and artificial intelligence, which is whatever intelligence exhibited by machine. I'm not going to go into the definition of what is intelligence and all this, but let's keep them apart as just two things. At least since the 80s, there's been two main movements in AI, the symbolic AI and the subsymbolic AI. Subsymbolic took many, many different names through the year, from connectivism, neural nets, machine learning, and we're continuing with this. So fundamentally, the difference, and all of you here know, but maybe some folks don't know, the difference is that on the symbolic side, we're treating the whole notion of intelligence or reaching to doing some symbol processing, where on the subsymbolic side, we're trying to imitate the neuron structure and the firing of these neurons. So two different views of how we can achieve AI, basically. Since my grad studies in the 80s, I've been a naysayer. I've been against, or I've been talking down subsymbolic and neural networks, I admit it. But we've always seen, and I've always believed, that subsymbolic AI was really good at doing some of the perception and the sensings of the data. And symbolic AI was better for decision, and thus my support for DMN and this symbolic AI approach to this is decisioning that we're doing. But admittedly, and even from the beginning, so this has been true at least for 40 years, we know that symbolic AI is better at abstract problem, more useful for explaining people's thought, easier to explain. Knowledge elicitation has to be done up front, and that's been a big challenge. It's not so big data, it's easier to debug and easier to control. While subsymbolic has been much better at sensing and perception, very more useful for connecting it to neuroscience if you're studying in neuroscience, easier to scale up. And that's the big thing, and we're seeing it now. It's much easier to scale up, less knowledge up front. There's no elicitation of knowledge that needs to be done because of the learning capability. Big data, more robust against noise, certainly more robust. On the symbolic side, we had to jump into all kinds of heuristics as we're working, and much better performance on the subsymbolic side. So we need to put all these in the balance as we're going forward and looking at things. So jumping into what I've called Neuro-Symbolic, it's not my term, it's a term that's been around for a little while, but it's basically looking at how we can combine the best of these two approaches into a more powerful approach to going forward with AI. Now, then suddenly ChatGPT arrived end of November 2022, and like many of the other geeks probably in this room, spent my Christmas holiday playing with it because it was quite attractive, quite interesting. And what we saw basically is the advent of generative AI. Generative AI has been in the work for a while. A lot of us and a lot of people around us are seeing this as if it was brand new, but there's been work since the 2000s on progressing towards what's really in the face of everybody now. So it's not brand new. What's new is the fact that we were taken by surprise by ChatGPT. And I guess what's bringing so much conversation is the fact that ChatGPT really lowered the barrier to entry. And with that barrier to entry, we seem to have time to value that is much shorter. So it's very enticing. And as Gary just demoed, there is a lot of interest, and it seems like we can get to amazing things very quickly. But we have to look a little bit deeper to make sure that we're getting what we want. Now, admittedly, my emotional curve with this project followed the hype curve. So recognition to Gartner for the hype curve here. When I started during the Christmas holiday, I was a naysayer. I was like many people still on the internet, you know, saying this is just a parrot. It's just, excuse me, it's just providing, you know, predictive answers. It's not really useful. And then I started digging more into it. And at that time, OpenAI was just providing, and most models you could reach were just providing a completion API. So all you could get is basically a single prompt and a single return. And then I started getting interested in about how ChatGPT was kind of working in the background without any real publication that was explaining everything. But it was obvious that there was more behind it to maintain this conversation and everything. So as I progressed, I got really excited about the possibility of combining symbolic AI and in particular the triple count of BPMN, CMMN, and DMN, and how we could use that to scaffold what we can do with the large language models. I got really excited about that. And then publications were coming up, and basically pretty much once a week, there was a new publication that was changing the whole look of how things were going. By the time I hit July, I was pretty depressed about doing anything very useful. It seems like everything was all over the place. And then just recently in August, I kind of became more positive again about what was possible. And right now, I guess I got a more of a view of the world that is, there are really great use cases, and if we understand how we can characterize these use cases, we can do some great usage of that technology. Now, as I mentioned, I was running in front of a tiger. New publication speed is crazy by now. It used to be there was something in the first few months, there was big breakouts every 3 or 4 weeks. Then it became like every week there was a big breakout of what was possible and new techniques and everything. And by now it's every day. Every day there's multiple papers. Naturally, there's always been multiple papers published every day, but I mean groundbreaking papers that change the way we look at things. So this is evolving very, very fast, as was just presented by Gary. Within a few weeks of recording his demo, he went back and now there was more feature on the ChatGPT, but we're talking ChatGPT at OpenAI, but that could have been any of the other Vertex at Google or BART or LLMA or any kind of other model. Things are moving very, very quickly. And by now we're at the point where, everybody's asking, how will AI affect my company? How will it affect the labor market? Can I use this in a way without giving away all my data? It seems like it's sucking data for life. And in the meantime, we have all kinds of developers and technologists like ourselves that are experimenting to see new and creative use case to use that technology. So it's very, very interesting situation. So my big question of all this is to myself, really, and I guess to all of you, is, are we getting ready for the future of AI? Is this the future of AI? Or is this the AI future, as a lot of people like to chat about, and more on LinkedIn and on Twitter, I guess they're more talking about the AI future rather than the future of AI. So it is a good question. It's certainly a question that I've asked myself during this project, and I'll share some of my conclusion or non-conclusion with you. So demystifying generative AI, again, I'm not an expert. Yes, I've done my studies in AI and I've followed that. But like I said, things are coming out so quickly. I would have to spend a lot more time doing this than I was. So my caveat is on that. So let's start with large language model. Basically, LLMs are deep learning models, and they generate language output, thus the name large language models. So it is a language model in this particular case, and they have billions of parameters, so therefore large. So the large language model, the term very well specifies what they are. Now, another term that is used a lot, and I'm going to be using more, is the term foundation models, which refer to more general large models that were trained without any specific task. So I'm going to use the term foundation model pretty much across my presentation. Some people may take exception of me switching from LLMs to foundation models, and happy to discuss that and learn from you. So when we say large model, something probably some or most of you know, GPT-3 has 175 billion parameters and 96 layers. So that's where I started from. I started working more with the DaVinci Text 03 version. That's where I started. I'm now using the more advanced and the GPT-4, and there's a lot of inkling about what's coming up with GPT-5 in the research area. So GPT, that particular architecture, is moving very, very quickly. It's quite impressive to see how many parameters, but also how much training is needed to get there. So the whole idea of this approach is just feed in a lot of data, like big data. And we do the training on that, so we get a foundation model or a big foundation model. So these models are quite interesting to go. We're already seeing, and more is visible, certainly all of the different vendors are moving towards multimodal type of generation, so not just generation of text, but generation of code, generation of images, 3D generation, video generation. So the whole generational capability is going multimedia. And we're seeing some of it now, depending on how up-to-date you are. We've seen a lot of specialized model up until about 3 months ago, where you had models that were very well trained for generation, image generation, or text generation, or code generation. And we're seeing more and more these kind of foundational model that can generate any of the different types of modality. So I think we're going to see a lot more of that going forward. Prompt completion, just the core basic of everybody. So you get a prompt, you start a prompt, and the foundational model will try to complete what you started. Some interesting look at it for the AI crowd here is that it's interesting that we could kind of look at that as some form of predictive production rule, where I have an input X and I imply the output Y. And if you start looking at it from this point of view, it gives you a new view of what is generative AI and these models. And that's a little bit of the direction that I took when I started, is to say, okay, what if this is a component that has this very specific production kind of capability, and how do I attain this production rule type of environment? So in particular, prompt completion, the foundation model will basically just try to predict the next token. Now, it is a predictive model, so the behavior is stochastic. So the behavior itself is stochastic, while the actual action is predictive. So sometimes that randomness is very interesting when we want to do things in a creative environment. So the fact that it's random, that will generate new ideas, new way, will complete things in a different way, that's very enticing. And we've seen a lot of uptake more in the creative side of use cases. But sometimes this creative randomness is not really interesting, because we want a really factual context. And business are certainly more on the factual context side, well, depending on the kind of business, again, I guess, than the creative side. Now, some of the main settings, and I'm coming back on that because some of the discussion before with Gary, I think, are addressed by some of these little minor points here, and I'm sure he's aware of those, but they do answer some of what's going on. So the basic unit of work is the token. So it's basically a token is just a word, basically a word, but not quite a word. And two of the main settings are temperature and top P. And temperature, and the general idea is you shouldn't use both of them, temperature and top P together. You should only manipulate one of them. Otherwise, you're really asking for trouble in the generation. But temperature is a very interesting parameter. And the fact is that, and I thought that was a nice little thing that I've learned, and I don't know if it's actually the fact, but to me, it makes sense that if you raise the temperature of your model, the chances are that it's going to get fever and start hallucinating. So basically, by setting the temperature, you can really control the stochastic nature of your model. And you can actually get it down to a temperature of 0, where it's actually going to be deterministic in its production. So it will actually give you the same next token every time if you put the temperature to 0. And I don't know that for a fact, but my understanding is that ChatGPT is running at 0.8, so at quite a high temperature for running. So a lot of the models that you see exposed to the general public are exposed with quite a high temperature to basically enable this capability of being more creative, and every time you generate, you get a new answer, and all these, which seems to be desirable in this enticement of the population. But as we get more technically with it, we may want to lower the temperature to get what we want in a more deterministic way. So fundamentally, just general understanding. So tokens, you can see in the first sentence, tokens are mostly words, and then there are some example of multi-token words like demystifying here that's broken up into multiple tokens as opposed to a single token. And basically, when I'm playing with the temperature of my foundational model, I'm moving. So if I start my prompt, the sky is, the model will try to predict what the next word should be. And it will come with a list, blue, clear, cloudy, dark, beautiful, and many other possible words. And then we'll rank them in terms of the more likely or less likely word. And then if your temperature is high, it will randomly pick into there. Or if your temperature is low, it will always take the first one. So you will always get the sky is blue. So that's how, just, again, a layman's explanation of what's going on. There's a little bit more details and intricacy in all this, but that's generally what's going on. Now, the prompt completion has a lot of challenge. Hallucination is one of them. The training window, the fact that there was this limitation of the training data from GPT-3, which was 2021, I believe, and now we're climbing up with GPT-4 and all. But this training window is also a limitation. On another aspect or perspective, the cost of the API is also a challenge. The latency of the API that you have to wait for. So if you're trying to build system using these kind of technology that are exposed now, cost and latency are an aspect. And then there's all the ethical and bias and copyright challenge. Plus, they're all the bad agents type of action, like prompt injection and attack on your completion. So there are different challenges, but then again, they're not unbearable. They're all things that we can tackle and look at and see how we can improve on that. So one thing that became clear as things progressed, at least in my journey, is how do you get the model to do what you want or have the model that is fit for your purpose? At the very highest level, there's two ways of doing it. So you start from a foundational level. Now, there's actually the core. You can train from scratch a new model, but that's quite prohibitive in terms of cost and processing power. And that's why pretty much only the very large corporation can create those kinds of model. But then you can do some fine tuning. Well, you'll take your model and you'll retrain it to be better at particular task or domain and specialize their model. There are, I was going to say hundreds, but it's now in the thousands. If you go to Hugging Face or other places, there's so many different models and fine-tuned models that are available. On the other side, there's what's called in-context learning, which is what most people have been seeing and using, which is basically trying to manipulate the behavior of the model via prompts and conditioning. So I'm going to get onto that side most into what I'm looking at and what I've explored. So if you go into this right-hand side, which was the in-context learning, there's the whole idea of the prompt, working with the prompt. And actually, the term prompt engineering kind of appeared as I was progressing to this project. I was, like everybody else at first, playing on the prompt hacking side, so trial and error techniques of crafting the prompt, a little bit of what we see everybody. We try something, we change it, we see if it changed the behavior. Sometimes we don't know why the behavior changed and all this. And there's been the development, and it's coming very fast, the notion of prompt engineering, where we're trying to be more effective and efficient at creating prompt so that the model will provide us with the desired response. Now, so prompt engineering is basically just an emerging kind of capability. The word engineering may be a little bit over the side here, but it may end up to become more of an engineering approach. And the idea is that we're crafting prompts very carefully, and we're making sure that the way we craft the prompt will ensure that we get the generation that we want within a certain range of what we want, and we can scaffold or shackle this prompt, this generation, to provide us the completion that we desire. Now, a lot of prompting techniques have been developed and are still developing as we start. Originally, OpenAI, which was the first one really to expose an API publicly, was only offering, a single prompt completion type of API, while ChatGPT was doing this rounding thing. And so we started looking at different prompt templates, structured prompts, and role-based prompts. So role-based prompts started to evolve to kind of emulate what ChatGPT was doing. Now ChatGPT itself has embraced the role-based prompt, and now in ChatGPT, you can have an actual chat API that will give you instruction in the two role of the assistants and the user that you can intertwine. The notion of few-shot training, which is the capability of these models to do better when we provide them example. There's all kinds of data showing the benefit of providing examples so that the generation will follow more of the idea of your example. The whole idea of prompt pipeline and prompt chaining, which is to have multiple prompts and feeding the result forward in a Unix type pipeline or in more of a more evolved chaining. Thus, a little bit of what I'm talking about here, which is, and I'm going to get into, which is about learning BPMN and CMMN to orchestrate these things. Something that became more and more popular, which is the retrieval augmented generation, which was brought forward mostly for some of the business intent of and addressing the window, the training of the window, and the particular knowledge element. And then the new things that are progressing very quickly, the REACT framework, which is reason and act, the chain of thought, which is to think in step, the tree of thought, which is basically to do some traversal of trees of steps, graph of stops, program simulation. And interestingly enough, if you look at all these approaches and you take a step back, well, once again, we're reinventing the wheel in computer science like we like to do. We just basically redo everything and call it a different name. But fundamentally, what all these approaches are progressing towards is they're rediscovering what us symbolic people have been doing for 40 years, which is to have some kind of cognitive architecture, the belief, desire, intention type of the BDI type of architecture or the SOAR architecture. And they're basically piece by piece rediscovering those notions, hopefully applying them in some cases and just giving them new names, but they're basically progressing in that direction. So my interest at first and still remains, how do we create application with generative AI? And my biggest, I guess I don't want to jump to the conclusion too fast, but there was an interesting tweet from Grady Booch, and he said, then it's a simple matter of programming. Today, it's a simple matter of training. And he concludes, it was never simple then, it is not simpler now. So we still have a lot to learn, just like we still haven't really mastered how to do software engineering and production of software. I think we're very early in the Gen AI side, but it's moving a lot faster. So this cycle time is a lot faster. So continuing on this, comparing software engineering and prompt engineering, fundamentally, and I think Gary reflected that very well in his comments, on the software engineering side, we spend a lot of time on the development, and then we hopefully spend less time on the debugging and improvement because we did some good engineering and some good design to lower that. What's really happening on the prompt engineering side is kind of like the opposite in the term of the time expanded or the resource expanded, is that the initial development of the prompt can be very quick, but then to get it to actually do what you want is a long experiment and debugging and improvement. So that's very interesting. Put some more, the difference between implementation and experimentation, loose coupling, and we're interested in chaining dependency because that's giving us what we want, looking for quality, and more insight via evaluation rather than confirming via a unit test. So it's a different way, a different paradigm, and I don't know if we'll be able on the prompt engineering side to move it back to what it is on the software engineering side, and it could be, and I think it is possible, and I'm certainly hoping that some of the ideas that I'm pushing forward here are pushing us in that direction. So let's talk about data requirements. So if you're going to create a generative AI app or apps, you have to be aware of your data requirement. Now, if you're going to train from scratch your model, your own model, it's going to require an amazing amount of data. And it's probably data that you don't have. So if I'm a business and I want to train my model on doing a particular thing regarding my invoices, you don't need just a few invoices. You need millions of invoices to actually train a foundation model yourself. And that's why there are the other approach there where we can start looking at fine tuning. So I can take a generic foundational model and fine tune it to my particular case. But fine tuning requires a lot of data scientists and a lot of analysis and data manipulation that you may not have the expertise in-house. But there's a lot more AutoML that are coming in and will maybe accelerate the fine tuning. Then another piece that got another slice that got wedged right in there is the RAG, the Retrieval Augmented Generation, where you're actually providing documents as a source of information for the model to generate from. Gary did a demo of that, and I'm referring to Gary. He was the only speaker before me. So Retrieval Augmented Generation is basically providing documentation, some knowledge, and then prompt engineering at the end is just basically trying to manipulate the prompt to get your app, if you want to generate. Now, this gives you a sense of your data requirement and the type of use case that you have. Now, interestingly enough, up until today, the two main applications remains the building of customer service chatbot and answering question based on document. That seems to be, at least what I'm exposed to, the two main use cases that are tackled by people. And something we have to be mindful too, although this is very exciting and ChatGPT and Bing and all these tools that are coming and the power they're bringing us is very interesting, but we have to look at it from a business perspective. And if you look at the revenue versus the use case, we see that, you know, as we can tell from the companies that are investing a lot into this technology, the applications long tail is basically, you know, ad and search, where we're seeing a lot of these large companies investing because there is a potential return on investment for them. And then we have those mass market appeal type of apps, probably more B2C than B2B. And I would argue that probably the B2B type of application are going to be more in the specialized market, where because you're in the specialized market, you may not have as much room for creating apps that are really profitable. Now, although I've charted this as revenue versus use case, you could have charted that in terms of differentiation, and probably in this range here of the specialized market app, differentiation may be hard to hold on to as things are progressing so quickly. So finally getting to the point of my presentation. So the whole idea is to look at how can we combine the benefits of low-code model-driven apps, as we know with BPMN, CMMN, and DMN, and combine them with the generative power, or the power of generative AI, in order to create applications that are very interesting and better at creating them. So the whole idea is to create a generative AI feature set. So that is to create building blocks so that we can use these generated AI building blocks and compose them into an orchestration of the desired application or behavior that we want. So fundamentally, the idea is to do Gen AI orchestration, and to do so, we'll want to exploit things like structured prompt, different generative AI components that can be used, for example, summarizing or answering question, the power of foundation models to do the completion, BPM Plus to intermix all this and make sure that we have a control explainable environment, the use of vector database for RAG and retrieval augmented generation and embeddings, action connectors, and the use of planners, the use of memory manager, the use of OpenAI connectors, so we can do it. And by the way, when I started with this project, ChatGPT was just basically offering structured prompt. It was letting you provide structured prompt. By now, ChatGPT has integrated the retrieval augmented generation, where you can provide a document. It also implemented a lot. The memory was always there, and I'll talk a little bit about that. And I think we'll see a lot more of the planner capability as we move forward. Now, very interestingly, also, any of these components can be a generative AI component. It's your choice. It's a choice of the person that architects is application. So the most simple application you can think of is basically, just a user. We provide that to a foundation model to generate a completion. And a very simple example. So let me go and jump out here. So here is a very simple orchestration. I'm making a call to OpenAI. In this case, I'm providing a text, and I want to have a sentiment. And all I need to do is provide a prompt that does classification. And now suddenly I have a sentiment analysis application. So let me just use it through the form. And submit it. And it says this is a positive sentiment. Now, for everybody here, it's nothing very extraordinary. What's kind of really interesting, though, is that in order to do what I just did just 6 months ago or a year ago, you would have had to fine tune or train a model that was specialized. And that's what we had. Different vendors were offering fine tuned models or models that could do sentiment analysis. Now, using an API to a foundation model, I can create a sentiment analysis application just with one structured prompt to the system. So imagine the saving in time and in cost now that I can generate these kind of applications. And that's what's very enticing, is how fast and how quickly we can generate application, even though it has all the drawback of what we've talked before. So some of those reusable components we can create, for example, a structured prompt generator. So a way that will use a tool or an app that will use the best practice of prompt engineering as they're evolving, because they are evolving very quickly, to generate the best prompt fit for the purpose. A simple question and answering type of component. A text summarization component where we just basically have a shorter version of the text. And I'll talk a little bit how these can come all involve into your application. Sentiment analysis, as I just saw, text translation, text expansion, generation, image, and all these. Now, what's very interesting is you start looking at how you can use all these different components and start orchestrating them to have the app you want. And this allows you to have this more constrained components that is more structured and is behaving more like you want, and orchestrate them in a organized and explainable way. So another example is basically just to orchestrate a user input into a structured prompt. and then the foundational model and get the completion. So a little example of that would be here. All I'm doing is I'm asking some parameters, and I'm generating a structured prompt, and I'm passing that prompt to a foundation model. OpenAI I'm using here. I've done this. We have a model selector, so I can call Hugging Face models or any other kind of models that I want, Vertex, to do that. And then when you look at the structured prompt, then it allows you to do a little bit more guided and structure. And basically what I've done is I went and extracted all the best practice in structuring prompt. And so I can ask the age-old question, why did the chicken cross the road? And then I can ask and structure my model to take a particular role. So that's one of the best practice that's been around, is to tell in your prompt the role you want the completion to do. And you can take different role here. So let me take as a detective, because that's a question. And then I can select a tone. So I can also provide guidance to the model of taking a particular tone in doing this. So let me ask him to be emotional. Different tasks, to brainstorm, to create, to code. I just won't put one there. Different format. So let me put that I want to create in this particular case, a diary entry. And the style, I can ask it to be creative, didactic, more epistolary. So let me ask him to be, I don't know, argumentative. And then how long do I want? Do I want a concise or long answer? I'll just ask for a short paragraph. So as I'm going forward here, I'm providing all kinds of guidance so that my submission will take a particular approach. So now you see, this is a diary entry for my detective as to what he thinks basically happened in his investigation. So today was presented with a perplexing case. I was asked, why did the chicken cross the road? After much investigation, I have come to the conclusion the chicken crossed the road in order to reach the other side. I'm still unsure of the chicken motivations, but I'm certain that the chicken was determined to reach his destination. Now, as you're going forward creating these components, you can also add all kinds of other parameters like the temperature. So for example, in many of the components that I've created, I've made sure to keep my temperature to 0 so that anytime I was asked the exact same prompt, I would get the exact same generation. So that way, the generation is more in terms of a structured application rather than a creative kind of constructing. Now, so did that already. So now another aspect that is very interesting and somewhat not perplexing anymore, certainly not on the research side, but on the business side, is that there's no anchoring of what ChatGPT produced on actual sources. So we get all kinds of return and completion, but without really kind of referencing or details. So retrieval augmented generation is a way to improve that, where what we're doing is we're taking some existing documentation. So we'll take documents and data and include this into the query so that we can ask the question within that context. So we'll basically scaffold the foundation model to generate according to what's been provided there. And these chunk of text will then be provided back as the source for generating the text. So rather than generating from broad knowledge that the large model has, it will generate from the extracted chunk. And the whole idea is to come and bring the chunks of knowledge that are as similar as possible to the question that you're asking. Now, this is a little bit more complex, although as Gary demoed, from a user point of view, you just put a file there and it uses it and it's interesting. So fundamentally, you can think of this as a two-phase process here. The document or the documentation is broken into chunks, and then we'll add metadata to the chunks to know that this particular chunk comes from this document or this section of this document. We'll generate an embedding. An embedding is basically a vector in a very large vector space that represent or capture that chunk, and we'll store that in a vector database. And then when we get a question from the user, we'll turn that question from the user itself into a vector, and then we'll go into this multi-vector space and do similarity computation. So we'll basically find the nearest neighbor type of thing, and then out of that retrieve from the vector database all the chunks that are the closest, and then pass those chunks to the foundation model along with the question, so we get the completion. So already you see there's a lot more kind of orchestration taking place there than maybe just a prompt completion. So let me show you quickly this idea. Let me go into the retrieval augmented. So here I'm going to go pull a file from my desktop. I'm going to take a Trisotech. Let me go see that file. I'll show it to you. Just a second. Sorry about that. Should have got ready for that. And I didn't. So here's a PDF about a case study that Trisotech just published in the last month and a half or so. So basically, there's no way for the foundation model to know anything about this particular case study. Not only it's brand new, it is in a proprietary PDF behind a download wall. So I can provide that PDF and ask him. And submit this. And now the tool is going through all that process, that orchestrated process that I showed you. And it's coming back and saying the results, is that the e-pneumonia application developed by Intermountain resulted in significant decrease in 30-day mortality. More than 100 lives are saved. And it goes on explaining the contribution and what's done. And if I bring that document back again, which I probably close, which is not a good idea, but you can see that right there, one of the highlights right there is more than 100 lives. And it's got all kinds of different statistics about outcomes and 30-day mortality and all this. So basically, the completion was purely based on that document. So it didn't create all kinds of hallucination. So obviously I was keeping my temperature very low. I was making sure that it was only generating from the provided chunk that I was giving to the model for the generation. So again, all kinds of different techniques that are coming into play. And these techniques are now part of really the ChatGPT or the other model. And I'm sorry if I'm using ChatGPT over and over again. It's like the good old thing. People still call a snowmobile a skidoo because they were the first brand. So probably GPT will stick as the default name for these kind of agents, but I don't know. So as we progress, more interestingly, we want to go into chatbots and agents. And again, as I mentioned, the technology is catching up to what I was exploring and doing and actually passing me along the way. But it's interesting to see how we can develop those things ourselves too. So, and I'm making a differentiation here between a chatbot that is basically just conversational and an agent as a system that can actually take action. Now we can argue about, well, they're both the same or whatever, but I want to make the differentiation that one takes action where the other one doesn't take any action. So, and for the sake of time, I'll try to accelerate my pace to get to the end. But fundamentally, ChatGPT, my first exploration was, well, I only have text DaVinci 03, I have a text completion. How do I create a chat kind of an environment? And basically, you find out that it's quite simple. You just have to provide memory. And basically, that's what ChatGPT does, is that as you're interacting with it within a particular case, it will keep the different interactions and inject them at the generation. And so here's something that we've learned in symbolic AI in the 80s is, oh, it's great to have the notion of memory manager. We may want to manage long-term memory, short-term memory, semantic type memory, and revolve that. So basically, the chatbot is just this loop of injecting and memory. Now, what's very interesting is that in the first few months when I was experimenting, the limitation of the size of the prompt was quite tight with the DaVinci 03. It got better with 3.5 and quite large with 4 now. So what you can do then is you can add, I didn't show it here, but I could add a summarizer component at the exit of the manager of the memory. So I can take the memory, summarize the memory very tightly so that I use that. So then you can combine all these different pieces and orchestrate them into what you want. And when we look at agents, the notion of agents is quite similar, except now we're adding the notion of a planner that we've been working in symbolic AI for quite many years, memory manager, possibility of taking action to affect the environment, and then get the generation back. And ChatGPT is there now, so it has its, I think it's called functions, which are these actions that it can call, a little bit of planning, and that's certainly where the tree of thought, chain of thought, and all these ideas are pretty low-level planners, but we could put here some very advanced planning technology that we've developed over the last 40 years. So what's really interesting is that any of these components can themselves be a Gen AI component. So my memory could be a textual memory that I basically keep as natural language text that I can summarize, or I can have a more structured type of memory and still manipulate all this. So accelerating a little bit here. So the whole idea, I like the term Copilot. So in the recent few months, the term Copilot became very popular everywhere. I like the term Copilot. It brings the notion of these tools being there to support human in the loop so that we scaffold them rather than shackle them. We don't want to shackle our knowledge worker. We want to scaffold them with things that are providing interesting next step or decisions. And by the way, this is very similar to the progression we have in aeronautics. I was an aeronautic engineer in my young years in the Air Force. And at the time, I remember in the 80s, the big debate was about, you know, all the technology. Should it control the plane, or is the pilot controlling the plane? And then there was the big advent of Airbus. Airbus became kind of the engineer aircraft, and Boeing was still the pilot's type of aircraft. And we've seen this progress through time to where we are today. And we're leaving a lot more space to the Copilot now than we used to, the electronic Copilot than we used to. And I think that's something we'll see in many different areas as we progress. So trying to complete here so that Jacob doesn't stop me. Lesson learned, we're very early in this. Like, this is really, really, really early, and it's progressing faster, faster, and faster every day. Gen AI completion is random. So sometimes it's desirable if you're in a creative context. If I'm writing emails, if I'm writing marketing, if I'm creating new positioning, the creative nature is something that I may want. Sometimes it's not. In business, in certain situation. I don't want my business decision to be creative. I want them to be fixed and explainable. Use Gen AI where it's effective. I mean, it's great at generating language in particular. It's becoming great at generating multimodal element. But my question is, why use, I see so many people debating on LinkedIn and everywhere, oh, you just ask it 1 + 1 and it doesn't get it right. It's like, who cares? That's not what it's for. I mean, we know how to do 1 + 1 in the chip in memory so fast. Why would I go do 1 billion computation of nodes to compute 1 + 1? I mean, let's stay with what it's good for. And Gen AI is not the app. And that's what a lot of people are mistaking right now. It may become, but it's not. Right now, it's a great interface. It's a great language-based interface, and now it's going to become a multimodal type of interface, and it's at best a component. It should be basically orchestrated with other programmable components. So my conclusion, are we just getting ready for the AI future or the future of AI? I don't know, honestly. I still don't know. I'm not yet completely sure that we're not just in a Gen AI bubble, but we're certainly, maybe we are in a Gen AI revolution, and it's going to be the leading way in which we do things. Use Gen AI technically fit use case. Don't use Gen AI to do mathematical problems. It's not good at it. I mean, Fortran is better than Gen AI to do math problems. So we all know that. So let's not use that. And for somebody that did AI in the 80s, man, this is very interesting. Suddenly I'm proud of my AI degrees, which I was hiding for the last 30 years, never said I was studying in AI. Now suddenly makes sense. I had a drink with my neighbor last week, and he asked me, what are you working on? And I said, oh, I have this great project in AI and all this. I said, it's really interesting because, that's what I studied when I was in school. And he said, this is only 6 months old. How can you have studied that? I said, no, we've been doing AI for 50 years. It's just becoming to the general public awareness now. And so the real conclusion of this and all my experimentation, and I really think that the time for Neuro-Symbolic has come, where we take the Gen AI and the Subsymbolic AI for its feature and benefit, and we combine it with the orchestration and the learning we've done in Symbolic AI. Let's not wait till they all reinvent the SOAR architecture. In the mid-90s, I've used the SOAR architecture a lot to create multi-agent system for military training system. Did that in 93, 94. It was a huge success. They're bound to reinvent SOAR and BDI and all these different cognitive architecture that we know about. Let's scaffold them with that and improve the speed. And I'm going to leave at least a minute or two for question if I can. I'm sorry, I've been a little bit long.
Thank you, Denis. Very, very interesting. And again, brave, I would say, these days. And we do have several questions and several comments people can read in the Q&A tab. But Ron Ross is asking about your document loading. PDF documents, how difficult it is, can it be done by non-technical person?
Well, as I shown in this example, basically the example I was showing running, it's a service. It's itself an API. So I've created from the orchestration of BPMN, DMN, and CMMN, and all this, I've created a service. You just call that API, you provided a document, and it does the answer. So wrapped up like this, it's very simple. Now, the structure, as I showed, is very complex, and you have to understand, multi-dimensional type of vector analysis and what's the best way to find the nearest. But all these are being packaged under things, and I've done some example, but there are different tools that are evolving, doing, and to go to Ron's point, I've shown a PDF one, but right now what I've modeled is only with PDF. If I wanted to use Excel sheet or Word document or other, then you need different type of document reader, document loader that will do the chunking on that particular type of document. But again, that's something that you could put in front of what I've done and add that. And actually, ChatGPT does that. You can give it an Excel sheet or a PDF or anything.
Yeah. Thanks. And the most important thing probably is that you don't have to format your document in special ways. That's what ChatGPT does. That's the most important thing. And I cannot resist, even if we have only 2 minutes left, to ask questions what Gary initiated, and it's on mind of everybody who does this. It's what is yours, in your point, what is the source code? Is it prompts? Is it part of generated files? What is source now?
Well, my view of it, and I may be proving wrong, but my view of it is Symbolic should be king and Symbolic AI should control all this. And therefore the code is the Symbolic model, which we can explain and structure as we want. And the Gen AI is just a subservient service that we use as needed. Okay. That would be my answer today. And again, I said today because honestly, OpenAI, well, it's true that I was alone and they have a few hundred people developing, but ChatGPT was just breathing in my neck. Every time I would develop something new, they would come up with it as a general release. But it's moving fast. It's moving.
Okay.
Really fast.
Thank you very much. We need our time is up. Thank you, Denis. It's a great presentation. And now let me stop this recording and